This section is just a very short review of some concepts and reagents that we learned back in the alcohols chapter. And you should remember from the alcohols chapter, the aldehydes and ketones can be reduced to an alcohol using a hydride reagent. And the two hydride reagents that we looked at were lithium aluminum hydride, which we abbreviate LAH, and sodium borohydride, which is NABH4. There's no abbreviation for that. So remember that the reduction of a ketone or aldehyde or ester with lithium aluminum hydride is a two-step process. The first step is going to be your lithium aluminum hydride, and then the second step is going to be to treat it with water or aqueous acid. So let's put that in here, or H3O+. And that with sodium borohydride is a much milder reducing agent. And so it's a one-step process where you just have sodium borohydride in your polar protic solvent. Here they put methanol. You could also use, we'll put here, or ethanol, or even water sometimes is used as a solvent. Now keep in mind that both of these reactions are irreversible, and the reason why is because hydride is not a good leaving group. It cannot leave once it gets added to your carbonyl. And here's the mechanism here, basic conditions. So the first step has to be a nucleophilic attack, not a proton transfer to make an oxonium. So this is lithium aluminum hydride. Step one is going to be your nucleophilic attack. Then you make your alkoxide, which is shown here. And then in step two, you treat it with water or aqueous acid. And it does the proton transfer to give you the alcohol. And of course, we always keep in mind that a carbonyl carbon is sp2 hybridized, and it is trigonal, what? Planar. It's flat. And so when the aluminum hydride, I'll just pencil it down here, when the aluminum hydride ion, or the hydride, does the nucleophilic attack, okay, it can attack from either face of the molecule. It could attack from the front, or it could attack from the back. And that is why after aqueous workup with water or aqueous acid, we would end up with a racemic mixture in this specific case. So remember, when you're forming a new chiral center and you're using lithium aluminum hydride or sodium borohydride, you're always going to end up with a racemic mixture.